So good morning, everyone. So my today's topic is mathematics for data science. The content that I am going to cover in today's talk is a little bit introduction to data science. We will see what is the difference between data analyst and data scientist. Then next, I will talk on different mathematical concepts which are required for data science. Then whatever the mathematics that you have learned in your +2 level or in degree level is sufficient for you to have a knowledge in data science, or you can apply that to the data science problems. So rather than discussing the definition and all, what I will do is I will discuss 3 applications in which you can see how exactly these mathematics are applied. So these are the content of today's talk. So if you are not able to understand any of the topic or concept, you can stop me in between and you can ask the question, or also you can send the question in your chat box, or you can type the question in your chat box. So let me start with definition of data science. As per IBM, data science combines the scientific method, maths and statistics, specialized programming, advanced analytics, artificial intelligence, and even storytelling to uncover and explain the business insights buried in data. So that means mainly we are using data science for getting business insights which are hidden in the data. To get that, what exactly we are doing? We are using the knowledge of mathematics, statistics, and computer science. And especially in computer science, we are using data mining, machine learning, artificial intelligence, then programming concepts like Python, R, and then information theory. All these techniques we are using to get the business insights which are buried in the data. So as the definition says, definitely data science is not a single disciplinary subject. So it is a multidisciplinary approach. So when you say multidisciplinary approach, to become a good data scientist, you should have some skill set in mathematics, statistics, and computer science. So in computer science, especially I told you, artificial intelligence, machine learning, deep learning, and information theory, then programming concepts in Python, R, etc. So what is required for mathematics and statistics, that I will tell you in the coming slide. So all the techniques or methods of modern data science make use of mathematics. Even machine learning algorithm, you require mathematics. So before going to explain you what are the different mathematical concepts that we use in data science, I want to give you the brief idea about data science life cycle. So first phase of data science life cycle is capture the raw data. So capturing the data means data is available in many formats. So you have to get the raw data. Raw data in the sense you may be having data which are both structured and in unstructured way. So collect the data. So that is your first step. So once you collect the data, you have to prepare and maintain it. So you have to bring it into or store it in a proper format. For example, if you are having a CSV file, that is comma separated file, then you can store that in a table. So how to store the data? What is the format that you need to store the raw data? How you can segregate this text, image, and audio in your data? Because when you talk about raw data, it can be having textual data, it can be having audio data, it can be having video data or image data. So you have to process all the data. So that's what you are doing in the second step. Third is pre-process or process. In this, you are going to do the data cleansing. You are going to pre-process the data with different pre-processing techniques available. So if there are some missing data, you are going to use suitable technique for coming up with some other values for that particular missing data. Then you can reduce the dimension of the data by applying some dimensionality reduction techniques like PCA, wavelet transformation, single value decomposition, etc. And after that, you are going to the next phase, which is the important phase, that is analyze phase, where you are applying data mining, machine learning, and deep learning concepts or any other predictive analytics concept to get the insight which is hidden inside the data. So actual analyze you are doing in this fourth phase. After that, you are communicating the result. Communicating the result means you are using the data visualization tools so that you can come up with the bar diagram, charts, etc. so that decision maker can understand what is the inside of the data and they can make the decision. So these are the 5 phases of data science, and other than capture, in all other steps you require mathematics and statistical concepts. So see this diagram. In this diagram you can see that there are, one second, can you see the pointers?
Yes, sir.
Okay. See, there are 3 domains here. One is mathematics, statistics, and algorithm. Another one is data communication, and third one is software engineering. Now, data communication means whatever communication I have explained to you just now, that is data visualization. So if you are good in math, stat, algorithm, and data communication, then you can become data analyst, but not data scientist. If you are good in math, stats, and algorithm, and you are good in computer science in the sense data mining, machine learning, then deep learning, then programming skill like Python, R, and all, then you can become data engineer, but not data scientist. To become the data scientist, you should have both the skill of data engineer and data analyst. So you should be good in machine learning, you should be good in deep learning, you should be good in mathematics, you should be good in statistics, algorithm. Also, you should able to use the data visualization tool and represent the data in a proper way using charts, bar diagrams, etc. so that the hidden insight is clearly visible to the decision makers and they can take the decision. Then only you can become the data scientist. So it is up to you which field you want to choose. Either you can be a data analyst only, or you can be a data engineer only, or you can both and you can become data scientist. But now the demand is for data scientist. Industry is not interested to take data engineer separately, data analyst separately, because they have to pay 2 times here. But rather than that, if they take data scientist, then they can do all the work and they can reduce the cost also. So the demand is for data scientist, but still there are scope for data analyst and also for data engineer. So any field, if you choose, whether it's a data engineer or data analyst or data scientist, you can see that the backbone of this is mathematics, statistics, and algorithm. Without this, you cannot become data engineer, you cannot become data analyst, you cannot become data scientist. So your basic mathematical skill, statistical skill should be very good to become data scientist. So why people are interested in data science is just because of job opportunities. So data science is one of the fastest growing technologies in the world nowadays. So according to IBM survey 2020, the number of job openings in the field continues to grow at over 5% per year. So about 11.5 million jobs will be created by 2026 according to US Bureau of Labor Statistics. So India Today survey August 2020 says that 96,000 data scientist jobs are vacant in India. So they are not getting the data scientist. They are getting data analysts, they are getting the data engineers, but they are not able to get the data scientists properly. So the demand is there, but supply is less. Therefore, all the educational institutions nowadays started the course of BTech data science and MTech data science and all those things because the demand is there. So if you are good in data science and if you are a good data scientist, definitely you are going to get a very good job, and the pay is very huge for data scientists. So they can earn 25 lakhs to 65 lakhs per year based on the experience and qualification. So the person who is having 3 years of experience may get somewhat around 25 lakhs per year, and the person who is having 10 years of experience will get 65 lakhs per year. And in the next year, they are predicting it is going to increase to nearly 1 crore package per year. Therefore, demand is huge. So if you master data mining, machine learning, artificial intelligence, then the deep learning concepts together with math, stat, and also with different data visualization tools, then definitely you are going to become a good data scientist, and definitely you will be paid very handsomely in the future. So now let us come to the mathematics part. So I am talking about mathematics only in today's talk because it's a 1 hour talk and I cannot cover both math, probability, and statistics in this. So one of the major domain which is used in data science is linear algebra. Linear algebra came into existence in 1800 year. Then it is also called as mathematics of data. Linear algebra is actually a mathematics of data, and you need not learn the entire concepts of linear algebra. You need not understand the Gilbert-Stank's book completely as it is. You have to learn only few concepts from linear algebra, but you should be good in these concepts. So what is linear transformation? Definitely, I hope all of these things you have studied in your engineering mathematics and also in +2 mathematics. Linear transformation, matrix operation, you require only multiplication, then finding inverse, then transpose of a matrix, then matrix multiplication I already told, I think, then trace of the matrix, then diagonalization of the matrix, then raw reduced echelon form. All matrix operation you should be good enough. Then vector spaces, because if you see the input for your neural network or machine learning model is either a vector or a matrices or a tensor. Tensor is nothing but more than 2-dimensional matrix. So you should know how to handle the vectors, how to add the vector, how to multiply the vectors. Then what do you mean by linearly independent vectors? What do you mean by linearly dependent vector? What is the basis of vector space? And what is the span? That and all you should know. I think already you have studied all those things. Then you should know linear least square. What exactly we mean by linear least square method? I think some of you have studied this when you have learned linear regression. Then eigenvalues, eigenvectors. This also you will learn in elementary mathematics. Then diagonalization, singular value decomposition. So these are the concepts you should learn properly from the topic linear algebra. And coming to calculus, you should have an understanding of limit and continuity, because we are going to use extensively the derivatives, partial derivatives, integration, etc. in data analytics. So to understand that, you require these concepts. Then what is optimization problem, and what is maxima and what is minima, what is infinite series, sum of series, etc. These things you have to give more importance while learning the calculus. Then third one is discrete mathematics. In discrete mathematics, you have to give importance for sets, combinatorics, countability, basic proof techniques, and graphs. Graphs you require for data visualization and also for some model analysis. Therefore, you should give importance for the graph theory also. Then, without knowing probability and statistics, you cannot become a good data scientist. So these are the building blocks of data scientist. So you should know what exactly you mean by mean, variance, correlation, basic probability theory, Bayes theorem, conditional probability, probability distributions, random number generator, hypothesis testing, linear regression, etc. So try to learn more about hypothesis testing because this is very much required. So you can compare different classifiers or output of the performance of the classifier using this hypothesis of testing. So you can compare two classifiers using Wilcoxon test, and you can also compare different classifier using Friedman test. So this is also important concept which you have to learn to become good data scientist. So only 5 topics are there: linear algebra, calculus, discrete mathematics, probability and statistics. Then in addition to this, one more topic is there, that is from information theory. Anyway, that is a part of computer science. In that you have to learn what do you mean by information gain, what exactly the entropy stands for, and how exactly the decision tree is constructed. So these are the concepts from information theory which you should have understanding to have to become a good data scientist, because information theory is required for optimizing the data model so that you can remove the unwanted data and you can store only the required data. So before going to the next topic, I want to ask one question to the audience. Can you define set? Any one of you? A simple mathematical concept.
It's an ordered collection of objects or something.
It's a ordered collection of objects. So if I say that handsome boys in this particular workshop, is that is a set?
Sir, could you please?
Hello.
Hello.
Yeah, whether it is a set.
Sir, could you repeat the words, please?
Okay, if I say that handsome boys, those who are attending this workshop, whether it is a set.
I think it's a set, sir.
Okay. Any other answer from any other participants? Okay, in chat also I am getting the answers, but one person told it is not, handsome is not defined. Very good. Anantram Vemuri. So yes, answered as handsome is not defined. Correct. Because if I ask you who are the handsome guys in this set or in this class, you may tell me few names. If I ask some other person, he may tell some other names, because handsome is depend on the perception, right? How you are going to perceive. So perception differs from person to person. So it is not ordered collection of objects. So people usually say that whenever we ask what is the definition of set, they usually say that it's a ordered collection of objects. So you are missing one point there. The definition of set says that it is a well-defined collection of objects. So it should be well-defined. So usually what people does is they miss this well-defined word and they are just saying that it's a collection of objects. So collection of objects is not a set, it's a well-defined collection of objects. Then only you can call it a set. Okay, let me ask one more simple question which you have learned in your elementary mathematics. Can you define tree? I hope all of you have learned graphs. Definitely you know what exactly you mean by trees. Any answer? You can type in chat or you can answer my question by unmuting yourself. Am I audible? Or whether my connection is lost? Because I am not able to.
Yes, sir, you're audible. Yes, sir.
Okay, because no answer is there in the chat box, and also I request participants to answer something.
He's answering in the chat box.
Branch of leaves. So tree is a data structure. Another answer is undirected graph in which any two vertices are connected by exactly one path. Okay, one person has answered correctly. So Swati BP. So connected acyclic graph is called as tree. So the simple definition is connected acyclic graph is called as tree. If it is having a cycle, it cannot be a tree. If it is not connected, it is not a tree. So both is required. If you say only connected graph is a tree, it is not correct. If you are saying only acyclic graph is a tree, it is not correct. It should be a connected acyclic graph. So simple definition for tree is connected acyclic graph. So what I am trying to tell you here is understand the definition and basics properly. So I am not going to talk about all these things like linear transformation, matrix operation, all these things, because already you have studied this. So try to brush up these things and try to understand the basic concepts properly of linear algebra. In linear algebra, especially these topics which I have mentioned here. Similarly, in calculus, these 4 topics. Then in discrete mathematics, these topics, and in probability statistics also, you should understand it in a very detailed manner. So whatever your understanding should be clear. So what I am going to do is in today's talk, I will take 3 applications in which this math and probability theory or statistics are applied extensively. So first application which I am going to talk is principal component analysis. Many of you may be already knowing this. So before going to talk about this, I should ask you, what are the different mathematics used here? Any idea? Okay, let me go ahead with this rather than asking more questions. I got one answer by Swati by saying that eigenvectors, correct? So mainly we are using linear algebra and statistics in principal component analysis. It is mainly used for reducing the dimensionality. Suppose you are having a table or a matrix of size 1 million into 1000. Then to process that 1 million into 1000 dimensional matrix, you require so much of time. In that 1000 column, some of the columns may be irrelevant or may not be required or not that much importance. So you have to reduce the dimensionality of your data. So to reduce that, you are using a technique called as principal component analysis. Other than this, many other dimensional reduction technique is also there, like wavelet transformation is there, singular value decomposition is there, many others. So I am going to discuss about principal component analysis. The PC algorithm has 6 steps. First step is standardize the dataset. Second step is calculate the covariance matrix for the feature in the dataset. Third one is calculate the eigenvalues of the covariance matrix. Fourth one is pick top k eigenvalues based on their contribution to total variability. Fifth step is form a matrix of eigenvectors corresponding to the selected k eigenvalues. Then transform the original matrix. So this is the steps used in PC algorithm. We will see each of the steps in detail. Now, if you see the algorithm, the first 2 steps, that is step 1 and step 2, require the statistics. For standardizing the dataset and for calculating the covariance matrix, you require the concepts of statistics. From step 3 onwards, it is eigenvalues, then eigenvectors, For this, you require the concept of linear algebra. So principal component analysis make use of linear algebra and statistics. And using these two techniques, it is capable of reduce the dimensionality of the data. So we will see that how it is going to happen. So here I have considered a matrix of size 5 cross 4. So that means I have taken the 5 samples from the table. Actually, my population may be more than 5, it may be 25 also. For training, I have taken only 5. So I am having 5 items here. Each item will be having 4 different frequencies, features, 4 different features. I am calling it as F1, F2, F3 and F4. So the dimension of this particular matrix is 5 into 4. Now first step of principal component analysis is standardize the data set. To standardize it, you are using the statistics. What exactly you are going to do is you are calculating the x mu value using the equation x minus mu by sigma, where mu is the mean of the sample and sigma is the variance of the sample. Sample means these 5 samples which you have considered here. Actually, in the data you may be having more than 5 items, but for training you have selected only 5 samples. Now why to do this x minus mu by sigma? Why you have to standardize the data set? It is for normalization. When you do this, what exactly will happen is you will get the new data set in which all the fields or all the features will be having mean is equal to 0 and standard deviation is equal to 1. Otherwise, what will happen is, suppose the value here is 1000 and value here is equal to 2. This particular field is going to dominate this particular second field F2. To avoid that, what exactly you are going to do is you are normalizing this data so that all the features will be having mean is equal to 0 and standard deviation is equal to 1. To do that, you are calculating x mu is equal to x minus mu by sigma. So mu you can calculate just by taking the average of this. You can see that 5 plus 1 equal to 6, 6 plus 1 7, 7 plus 5 12, 12 plus 8 20, 20 divided by 5 is equal to 4. So 4 is the mean of F1. Similarly, you can calculate the mean of F2, F3 and F4, and it is mentioned as 3.4 here. Now to calculate sigma, you have to use the equation for calculation of the sigma, which you have studied in your statistics course, which is given by square root of summation of xi minus mu whole square divided by n minus 1. Why n minus 1? Because I am taking standard deviation of sample. I have taken only 5 samples from the population. If I take the entire population, then sigma is equal to square root of summation xi minus mu whole square divided by n. For calculation of sigma of entire population, here it should be, denominator should be n, but since I have taken 5 samples, here it should be n minus 1. Now using that, I will get variance of this F1 or standard deviation of F1 is equal to 3. You can just check that. Mu of F1 is 4. So 1 minus 4 is 3. 3 square is 9. 9 plus 5 minus 4 whole square, that is equal to 1. 10. 9 plus 1, 10. 10 plus 9, 19. 19 plus 1, 20. 20 plus 16, 36. 36 divided by n minus 1. N minus 1 means 4. 36 by 4 is equal to 9. So square root of 9 is equal to 3. So like that you can calculate sigma of F2, F3 and F4. Now, once you get mu and sigma value for each of the feature, you calculate the new normalized data set, which is obtained by using this particular formula. X mu is equal to x minus mu divided by sigma. Just by putting these values and substituting and simplifying, you will get the value of F1 equal to this one, F2 is equal to second column, F3 is equal to third column, and F4 is equal to fourth column. Now, if you find mean of this F1, you can see that it is equal to 0. See, minus 1 plus minus 1 equal to minus 2. then 1.3 plus 0.3 plus 0.3 is somewhat around 1.99 to 2. So 2 minus 2 is equal to 0. Similarly, here also mean is equal to 0. So this particular data will be having mean equal to 0, mu equal to 0, and standard deviation is equal to 1 for all the features. So this is the first step. So in the second step, you are going to calculate the covariance matrix. Covariance matrix is always between two variables. Covariance between F1 and F2, you can calculate covariance between F1 and F3. You can calculate the covariance between F1 and F4. Similarly, F4 and F1, like F4 and F4. Whenever you try to calculate covariance between same variables F1 and F1, the covariance is nothing but your variance only. You can just see that in this particular formula. If both the features are same, here it will become summation xi minus x bar into xi minus x bar divided by n, that is equal to summation xi minus x bar whole square by n. If it is for sample, then summation xi minus x bar whole square divided by n minus 1, which is same as this particular formula for sigma. So covariance is equal to variance if you are finding the covariance between the same variable. If they are different variable, then you are using this particular formula. Now you are going to calculate covariance matrix for this particular data. So you are taking this entire table here. Therefore, you have to use the first formula, that is for entire population. Covariance of xy is equal to summation xi minus x bar into yi minus y bar divided by n. So now using that, you can just calculate this. You know that x bar is equal to 0, y bar is equal to 0, because in normalized data, mean value is equal to 0. So this is become summation xi yi divided by n. Just do that for this particular table. You will get the new table, which is here. So this is your covariance matrix, and size of the covariance matrix is 4 cross 4. Now next you want to calculate the eigenvalues of covariance matrix, and as you have studied in your mathematics course, to find the eigenvalues of a matrix, you have to consider the characteristic polynomial, and characteristic polynomial is given by determinant of a minus lambda is equal to 0, where a is the covariance matrix. So this is the covariant matrix. So find determinant of a minus lambda is equal to 0. You will get a polynomial of degree 4, because this is a 4 cross 4 matrix, and you are having a minus lambda like this. So if you try to take the determinant of this, you are going to get a polynomial of degree 4, and solving that, you will get 4 eigenvalues. And you can see one thing here, whenever you try to calculate the eigenvalues of covariance matrix, all the eigenvalues are positive. You will not get negative eigenvalues. So all the eigenvalues you are getting is positive, and you solve them in a descending order. So which first one is highest one, second one is the next highest one, like that you put it in a sorted order. So in this case, I have got 4 eigenvalues, and this is the descending order. Now in the next step, I need to pick top k eigenvalues. So now how to decide this top k eigenvalue? That is the question. I am having 4 eigenvalues, so I am not going to select all the 4 eigenvalues. I am going to select only a few of them. So I will see what is the total variability. Total variability is nothing but sum of these eigenvalues. So if I find the sum of all these 4 eigenvalues, I will get this equal to somewhat around 4. Now percentage wise contribution of this eigenvalue to the total variability, if I calculate that, I can see that lambda 1 I am calling it as eigenvalue 1, lambda 2 for eigenvalue 2, then lambda 3 for this, lambda 4 for 4th eigenvalue. So lambda 1 is contributing 62.89% to the total variability. Lambda 2 contributing 26.63% to the total variability. Third eigenvalue is contributing only 9.85%, and fourth is contributing only 0.63%. So I need to decide now how many values that I need to consider. So here I will decide that I will take only top two eigenvalues. So k is equal to 2 here, because if I consider top two eigenvalues, the total contribution that these two eigenvalues are going to do is 62, 63 plus 27 is equal to somewhat around 90%. So I will take these two eigenvalues. I will just ignore the other two eigenvalues. So using this eigenvalue, I will find the eigenvector corresponding to these eigenvalues. Now for finding the eigenvectors, I am using the equation Ax equal to lambda x, and I will solve that using Cramer's rule. I think all of you studied the Cramer's rule also. So using the Cramer's rule, I can solve the value for x, because determinant of A is not equal to 0. I can apply Cramer's rule here, and I can get the eigenvector corresponding to this particular eigenvalue. Now for lambda equal to 2.51579324, I will get these four eigenvectors, these four eigenvector values. So this contribute one column of the eigenvector matrix. So I will form eigenvector matrix. So in the first column, E1 stands for eigenvector corresponding to eigenvalue 2.51579324. You can see that here 0.161 here, minus 0.2 here, like that. So first column represent eigenvector corresponding to lambda 1. Similarly, the second column corresponding to eigenvector of lambda 2. Now initial matrix that I will take, initial matrix means the standardized matrix. That matrix is having order 5 cross 4. So that is the order of this particular matrix. This I am going to multiply with this 4 cross 2 matrix. I have considered the eigenvector matrix E1, E2, and order of this particular matrix is 4 cross 2. So I am going to multiply this with this. So I will get the new matrix, and the order of the new matrix is 5 cross 2. So initially the matrix that I am having is order of 5 cross 4, but now the transform matrix is having order 5 cross 2. So dimensionality is reduced here. Here 4 columns were there, but in the new transform matrix I am having only 2 columns. Now for data mining algorithm and for any machine learning algorithm, I am going to use this new matrix, not the old matrix. Now only this new matrix which we have got by reducing the dimensionality, that's what we are going to use. So PCA will come in pre-processing step where you are reducing the dimensionality of the data. Any doubt regarding PCA? So now we can move to the next application. This is a regression, how to fit a line. So all of you might have studied least square fit using linear regression. So I'm not going to talk about that. I'm going to talk about RANSAC method, which is called as random sampling and consensus. So regression will come in analyze phase where you are applying regression model to fit a curve to your given data. So suppose given data in this way, so your aim is to fit a line for this particular data. Then the problem is with the outlier. Outlier means this particular point, if you consider this is far away from this set of data points. If you consider this is also far away from this set of points. So if you use least square method, there is a problem that this outlier is going to affect the result of your least square fit. So we will see that in the next slide. So suppose I am taking one line like this, and if I am seeing that if the points are certain distance from this particular line, that's okay for me. I will consider that as inliers. So that means that particular points are actually near to the fitted line. An outlier means which are not fitting to this particular data. They are not belongs to this particular data. They are far away from this. So I will not consider this. I will just ignore these particular points. This is not going to happen when you go with the least square fit. So what will happen with least square fit is it will consider all the data points. So this is also considered. This is also considered. And if you actually see, this line is actually perfect fit for this data set because almost all the data points are near to this particular line. So this is a good fit. This line is a good fit for this particular data point. But because of these outliers in your least square fit, you may reject this particular line by saying that this is not a good fit. Because in least square fit, what you are going to do is you will calculate the distance from point to the line from all the points. So that's actually error, right? So you are actually fitting the line for this particular data point. So ideally speaking, all points should be on the line, but it is not practically, it is not going to happen. All points cannot be on the line to have a perfect fit. So you are considering the distance of the point from the line. This is called as error. So in least square fit, what exactly you are going to do is you are finding square error and finding the sum of that, and your aim is to minimize the squared error. So outliers will create a problem here because this will add more error to the total error that you are going to calculate. Therefore, even though this line is a good fit, your least square method may say that it's not a very perfect fit or a good fit for you because the error will increase here when you include this particular point. Now, how to find a distance from point to a line? You have to use this particular equation. Suppose equation of the line is ax plus by plus c is equal to 0. So this is the equation of the line, and the point is represented by m comma n. This point is represented by m comma n. Then distance of mn to the line ax plus by plus c equal to 0 is given by the formula. Distance is equal to absolute value of am plus bn plus c. That means you have to put the value of m and n in this particular line equation. You will get am plus bn plus c. If it is on the line, you will get 0. Otherwise, you will get the actual distance. So that is, you have to find the absolute value of that. Absolute value of am plus bn plus c divided by square root of coefficient of x square plus coefficient of y square. Coefficient of x is a square plus b square. So this is the formula for finding distance from a point to the line. So in such cases, least square method fails. Outlier is not the only problem. Suppose the given data looks like this, then here actually one single line is not going to fit this particular data. In least square method, what exactly you are going to try is you are going to fit these data points using one single line. So that is not actually a good fit. So that's also a problem. Here actually you require two lines, one line for this data and one line for this particular data. So multiple structure can also skew your result. So what is the solution? Simple solution is a ransack procedure. It's a very simple procedure. What exactly you are going to do is you select any 2 points randomly from the set of points. So here your probability come into picture. So with the equal probability, uniformly randomly, you select any 2 points and find the equation of the line which are passing through these 2 points, whichever point you have selected. See, the yellow colored points are selected, and find the equation of the line passing through these 2 points. So you will get this particular line. How to find the equation of the line passing through the 2 points? You know that you have already studied this. Suppose you have 2 points x1 y1 and x2 y2. Then equation of the line passing through these 2 points is given by y minus y1 is equal to m into x minus x1, where m is obtained by y2 minus y1 divided by x2 minus x1. So if you have 2 points, you can get the equation of the straight line which passes through these 2 points. So select 2 points randomly and find the equation of the line which passes through these two points. Now after that, you define a inlier. That means you define if the points are within this particular distance from the line, then they are inlier, otherwise they are outliers. So now the distance is defined in this way, in this particular boundary box. So here you can see that only 4 points are inliers and all other points are outliers. So what you have to do now? You select next 2 points uniformly randomly. So I will select these 2 points next uniformly randomly. I will find the equation of the straight line passing through these 2 points. Now again I will see how many points are inliers based on the distance formula. Now I can see that 6 points are inliers, other points are outliers. So I am not happy with that because I have many points. So what I am going to do next, I am going to take 2 more points. I will take 1 point here, 1 point here. Then I will find the equation of the line passing through these 2 yellow points. So I will get this line. Now I will see how many inliers are there. Now you can see 19 inliers are there. Then I don't know whether it's okay for me or not, right? So what I will do is I will keep on doing this thing. Next I will take another 2 points. I will see the count. There are 13 inliers. Then I will take few more points. I will do like that. Then best fitted line I am going to select. So what is the maximum inliers that I have got? That is for count 19. This is the line that I have got for which many points are inliers. So finally I am going to select this particular point. Now the question is how long you are going to do these things, because how many times you are going to run this particular equation, because randomly select 2 points and keep on doing like that. So if there are n points, finally if you choose all the points, it will take nc 2 times. If n is equal to 1000, then it will be 1000 choose 2 times. It will be very big number of iterations, right? So again the probability come into picture. Here it will say that you do not require that much amount of iteration. Number of iteration you can calculate using simple probability theory. So we will see how to calculate the number of iteration in this case. Define E is equal to probability that a point is an outlier. So you are going to define, suppose I am having 20 points, you can say that 4 points can be outlier, but see I need one line which have at least 16 inliers. So define this probability that a point is an outlier. Then S is equal to number of points in a sample. This is fixed for a line. So how many points you are taking for drawing a line? So we are taking 2 points to get the equation of the straight line. So therefore, when you are fitting it using a line, here S is equal to 2. Next, capital N means number of samples. That means how many number of times you need to run this. So what is the number of iteration? So this is what you are interested to calculate, this N. Then P is the desired probability that we get a good sample. So this P is again you have to fix. If you fix probability is equal to 0.99, that means with high probability you are expecting that you are going to get a good fit for the data point. So this you can give 0.99, 0.95, 0.90, it is up to you which value you want to give. So P you are defining, E you are defining, other things you have to calculate. Our aim is to find this capital N. So equation for the capital N is like this. We will see why this equation. See, for drawing a line you require 2 points. So what is the probability that choosing 1 point is a inlier? When you are selecting a 2 point, you are selecting first point. So first point is inlier. What is the probability of that? Probability that a point is outlier is E. So therefore, probability that point is inlier is 1 minus E. So that is for 1 point. You are selecting 2 points because for getting the equation of the line, you require 2 points. So both are independent event. You are selecting the first point, then uniformly randomly you are selecting the other point. So these are the independent event. So you know that probability of A into B is equal to probability of A into probability of B. If A and B are independent. So probability that choosing one point yields an inlier is 1 minus C. Probability of choosing S point in such a way that all are inliers is 1 minus E raised to S. This is clear. So when for a straight line equation we require 2 points, so this is going to become 1 minus C square. Now probability that one or more points in the samples were outliers. So both in S samples, all are inlier is this one. So 1 minus this one will give you probability that one or more points in the sample were outliers. So this is for one single iteration. So in all the iteration, suppose the sample you are taking is contaminated, the probability is 1 minus E raised to S whole raised to N, because again different iteration means they are independent events. So probability is this one, 1 minus E raised to S. So for the first iteration, this is the probability. Second iteration also this is the probability. Nth iteration also this is the probability. They are independent events. So probability of A into B is equal to probability of A into probability of B. Using that formula, this is 1 minus E raised to S whole raised to N. So that is probability that N samples were contaminated. Now the interesting point is, what is the probability that at least one sample is not contaminated? So that is 1 minus this particular probability. Probability that at least one sample was not contaminated, because we are happy with that. If we are getting one good sample, we are through. We got the equation of the line which is going to fit the data. So now this should be equal to the probability with which we want to get it. So this is equal to P. So what we got is 1 minus E raised to S whole raised to N is equal to 1 minus P, because P equal to 0.99. Now by simplifying this, by taking the logarithm on both sides, you are going to get N is equal to log 1 minus P divided by log of 1 minus E raised to S. So you got an equation for finding number of iteration, how many times you have to run this code to get the perfect fit line. Now let us see the example. N is equal to 12. So that means you have given 12 points, and we require 2 points for drawing a line. So S is equal to 2. Maximum number of outliers that you can have is 2. This is defined by you. So you are saying that 2 outliers are okay for me, but at least 10 points should be in layers. So in that case, the probability of outlier is equal to E is equal to 2 by 12, because 2 can be outlier out of 12 points. So 2 by 12 is equal to 1 by 6, which is equal to 20%. So 20% outliers are allowed. Now using this equation, log 1 minus P divided by log 1 minus E raised to S, you can see that when you substitute these values and find that, you are going to get N is equal to 5. That means within 5 iterations, you are going to get the equation of the line which is going to fit your data properly or desirably. But if you take 2 points and compare all the possibilities, then how many times you have to run your algorithm? You are having 12 points, and choosing 2 points from 12 points means you have to run it for 12 choose 2 times. 12 choose 2 times means 12 into 6 divided 12 into 11 divided by 2, that's equal to 11 into 6 equal to 66 pair of points. But using this probability theory, you have proved that there is a 99% chance that within 5 iterations you are going to get the desired line equation which is going to fit the data. This is very simple algorithm, nothing there. You have to use this particular equation to find the number of iterations. Then what you have to do is select 2 points randomly from the given point, then find the equation of the line passing through these 2 points, then see how many inliers are there based on the distance that you have specified to say that the point is inlier or not. Just see how many points are inlier. If you are through, then stop it. Otherwise, keep on doing it for this many number of iterations. In this case, it is equal to 5. So what are the pros of this particular method? It's very simple. It is applicable to many different problems. You can also fit the circle also using this. Then different curves also you can try to fit using similar kind of approaches. This often works well in practice because outlier you are going to define. So you can say that 4 points can be outlier, 3 points can be outlier, like that. But in least square method, you don't have that particular freedom. Cons is lots of parameter to tune. So you have to define how many outliers are there. So sometimes you may end up by defining more outliers. So that may affect your results. So here different parameters you have to tune. You have to select the probability value. Either it can be 0.99, 0.95, 0.9. That again you have to choose. So P is selected by you, E is selected by you. So you need to tune the parameters here. But sometimes even with that n formula, whatever we are doing, it is expected number of iteration. It is not actual number of iteration. Even if it says that 5 iterations are sufficient, finally you may end up running it for more than 5 times, maybe 66 times also. So in worst case, you may have to run it for infinite number of time also. But most of the time, it will give you within that expected number of. So here you have used linear algebra, because equation of the line and all you are calculating, and also you have used the probability for calculating the number of iterations. And using this, you come up with very simple algorithm for regression. That is, to fit for curve fitting, you can use a very simple algorithm which is a probabilistic in nature, but it is better than your least square fit. Any doubt regarding this? Can I move to the next?
Yes, yes, sir. I have a doubt with
Yeah.
respect to slide number 23. Yes, sir. This one.
Yeah.
The blue space that you have defined. How exactly do we get that? I mean, if I increase
that
the
is you
space,
have to define the error, madam. In the sense, see, you know the distance, right? Distance from the line equation, you know, that is this particular equation. What should be the distance of the point from the line? This you have to define again.
okay.
See, if I am saying that the distance is within a particular threshold, then that is in layer. Otherwise, it is not in layer. So the threshold value you have to define. How far a point can be from the line? That is again you have to define.
Okay, it's like we go on doing a trial and error thing
Not
there.
trial and error method. But first you have to define. Okay, later you have to do it in a trial and error method only. Yeah, correct.
Yeah, first we define something, and later on,
Yes.
if certain number of points do not come in the in-layer space, then I go on expanding it.
Yes.
Okay.
I
My
have an example. So it may be more clear to you when I talk about that. Let us see this example. Here I am having 3, 4, 5, 6, 7 points, and I am defining threshold is equal to 2. That means if the distance of the point from the line is 2, within 2, then they are in layers. Otherwise, they are not in layers. They are outliers. So what I am going to say is the line should fit at least 5 points. So that means out of 7 points, 5 points should fit to the 5 points should be in layers. That means I can have 2 outliers. So probability of outlier is E is equal to 2 by 7. Out of 7, 2 can be outlier. So probability is 2 by 7. That's equal to somewhat around 0.2 something. Then P I will choose is equal to 0.99. That means with 99% probability, I am going to get the correct fit for the given data. So N is equal to 7 here, and S is equal to 2. E is equal to 2 by 7. P equal to 0.99. Now I will use this formula. Capital N is equal to log 1 minus P divided by log 1 minus e raised to S. Using that, I will get N is equal to 7. So that means at the max I need to run this particular algorithm 7 times to get a good fit for the data. Now let me select 2 points randomly from these 7 points. So say 1535 this and 3065. So this is the 2 points I have selected. So my aim is to find the equation of the straight line passing through the above 2 points. So first I need to calculate the m. M is equal to y2 minus y1, that is 65 minus 35, divided by x2 minus x1, that is 30 minus 15. I will get m is equal to 2. So equation of the line is y minus y1, that is y minus 35, is equal to m into m is 2 into x minus x1. X1 is 15. So I got the equation of the line. By simplifying this, I will get the equation of the line is equal to y is equal to 2x plus 5. Now if I consider this as the equation of the line y equal to mx plus c, m is equal to 2 and c is equal to 5. I need equation of the line in this format, ax plus by plus c equal to 0. So I will take y this side. So I am going to get equation of the line as 2x minus y plus 5 equal to 0. Now these 2 points I have taken. Now I need to see other points are how far they are from this particular line. So I will find the distance of 5, 20 from the line 2x minus y plus 5. How to do that? In x and y, I will put this 5 and 20. So I will get 2 into 5 is equal to 10. 10 minus 20 plus 5. 10 minus 20 plus 5 is equal to 5. Absolute value of 5 divided by square root of a square plus b square. A is 2, b is 1. So a square is 4, b square is 1. The square root of 4 plus 1 is equal to 5. So I'm going to get 5 by square root of 5. It is equal to 2.23, which is greater than the threshold which I have defined. So this is not an inlier for me. So this is the outlier. So like this, you are going to define whether the point is inlier or outlier. So it is based on the threshold that you are going to define. Therefore, lots of parameter is there which you have to tune. One is E value, another one is P value, and third one is this particular threshold. Now let me take the second point, 1030, and what is the distance of the point 1030 from the line. So if I put that in this particular equation, I am going to get 2 into 10, that's equal to 20 minus 30, that is 10. 10 plus 5 is equal to 15. 15 minus so it is again equal to 5 by square root of 5. If I see here, 20 minus 10 is 30 is equal to minus 10. Minus 10 plus 5 is equal to 5. So 5 by square root of 5, again I am going to get the same value, 2.23, which is greater than 2. Therefore, this is also outlier. Now, if I consider the point 2045 and 2555, you can see that they are inliers, because if I put 20 and 45 here in this particular equation, 40 minus 45 plus 5, it is equal to 0. So that means this point is on the line. Similarly, this point is also on the line. So they are inliers. Now distance from 5103, if I calculate this using this particular formula, I can see this is equal to 2 by square root of 5. Square root of 5 is 2.23. 2 divided by 2.23 is less than 2. So therefore, this particular point is inlier. So I got how many points? 1, 2, 3, 4, 5 points inlier. 2 points are outlier. That is okay for me, because since my expectation is to have 5 inliers. So within one iteration, I got the result. So I am going to stop it here. Otherwise, I need to keep on repeating this until I get equation of the straight line which has 5 inliers. Is that clear now, or any other doubt?
Yes, sir, it is clear. Thank you.
Okay, now let us see how exactly calculus is used in data analysis. So all of you know the differentiation, I think, and differentiation is defined as rate of change. And you know that rate of change of distance is speed, and rate of change of speed is acceleration. So how to find the average? You know, sum of n values divided by n. This is also okay. Now differentiation is defined in your elementary mathematics as df by dx is equal to limit delta x tends to 0, fx minus f of x minus delta x divided by delta x, and which is called as f dash x, or which is equal to also called as fx, f suffix x. This all of you know. And also you know that if y is equal to x square plus x4, what is the differentiation of y? Similarly, if y is equal to sin x plus e raised to minus x, what is the differentiation of y? Because you here y is in the analytical form, since it's an analytical expression, you know how to find dy by dx. Now what you are going to do when you are having discrete values for a function? Now suppose consider a function f of x which is having the value 10, 15, 10, 10, 25, 20, 20, 20. So this is what you are having. Now how to find differentiation of f? That's the question. Because whenever you talk about data analysis or data analytics, you are having discrete data. You may be sometimes you may be having continuous data, but most of the time you are having discrete data. When you consider images and all, when you are digitally representing the image, it is going to become discrete data. Initially, if you consider it as a signal, then image is a two-dimensional signal, and it's the analytical, it's an analog signal. Sorry. Then when you convert it into the digital format, you are going to get the light intensity value only at certain points. So image is represented as a matrix usually. So you are having discrete values. Now how to find derivative of discrete function? So that is the question. Anyone knows answer for this? Anyone have studied this? Because whenever you have analytical expression, it is easy to find f dash x. Okay, now we will see how to find derivative of this function f of x. It is very simple. You know the equation of df by dx is equal to limit delta x tends to 0, f of x minus delta x divided by delta x. And since these are discrete values, it is countable. So we can directly take this delta x is equal to 1 here. So that means initially if it is x, then it is x plus 1, x plus 2, x plus 3, like that it is going. So delta x can be changed as 1 here. So there is no delta x tending to 0 here. Instead of that, you are taking delta x equal to 1 because they are discrete values, they are countable values. So you are counting first value, second value, like that you are counting. Therefore, delta x is equal to 1. So you can change that is equal to 1. So f dash x is represented as, calculated as f of x minus f of x minus 1. So derivative is nothing but difference here. So using difference, you can calculate the derivative of discrete function. So if you are calculating f of x minus f of x minus 1, that is with the previous value. If you are finding the difference of with the previous value, then it is called as backward difference. If you are taking the difference with the forward value, that is the next value, then it is called as forward difference. If you are taking difference using left and right value, then it is called as center difference. So any three of the method you can use to find discrete derivative. Either you can use backward difference, or you can use forward difference, or you can use center difference. So example, suppose you want to find f dash x. You cannot find f dash, suppose I am using backward difference. Here there is nothing back of 10. So I cannot find the difference of 10, derivative of 10. So derivative of 10 will be 0 only because there is no backward value. For 15, there is a previous value. So I can take 15 minus 10, that is equal to 5. So this is the differentiation of 15. 10 minus 15, that is equal to minus 5. 10 minus 10, that is equal to 0. 25 minus 10 equal to 15. 20 minus 25 is equal to minus 5. 20 minus 20 is equal to 0. 20 minus 20 is equal to 0. So this is my f dash x. Similarly, I can find f double dash x. F double dash x, to finding f double dash x, I require f dash x. 5 minus, so here initial value I will put it as a 0 only because there is no backward values. For 5, the difference is 5 minus 0, that is equal to 5. Minus 5 minus 5, that is equal to minus 10. 0 minus minus 5, 5. 15 minus 0, 15. Minus 5, minus 15 is equal to minus 20, 0 minus minus 5 is equal to 5, 0 minus 0 is equal to 0. So derivative mask that you are going to use is for backward difference minus 1 1, for forward difference 1 minus 1, for central difference minus 1 0 1. So if you have studied the convolution, then for finding the differentiation, you need, what you have to do is just you have to convolve it with the image. You will get the differentiation, or you have to filter the image with this particular mask. So these are the derivative mask used. So if you are having an image I, image is represented as a matrix. Just you have to do filtering of I with this particular mask minus 1 1. You will get backward difference or image derivative. You can use forward difference mask also. You can use central difference mask also. You are going to get the derivative of the image. So here I have considered one-dimensional function. When you talk about images, it's a two-dimensional function because you are having a matrix. So it is having fxy value. So here one more term comes that is called as gradient vector. So here differentiation of two-dimensional function fxy is represented by del operator, del of f of x comma y, where del is your gradient vector, which is given by partial differentiation of f with respect to x, partial differentiation of f with respect to y, and it is called as fx fy. And how to find partial differentiation in matrix? First you find backward difference for the rows only, so it is going to become one dimension. In that case, you are doing it for each row. Similarly, you find backward difference for column only, so then it will be for dou fxy by dou y. So this fx you can get by applying backward, forward, or central difference, any one of that, to the rows. This you will get by applying backward or central or forward difference to the columns. So you can get fx and fy. Once you get fx and fy, you can calculate the magnitude of the gradient, which is given by the equation square root of fx square plus fy square. Similarly, you can calculate the direction of that particular gradient, which is given by the formula theta is equal to tan inverse fx by fy. So this is for two-dimensional case. Now in n-dimensional case, here f is a function with n variables x1, x2, etc. xn. Then gradient is represented by dou f by dou x1, dou f by dou x2, etc. dou f by dou xn. So that means partial differentiation of f with respect to x1, partial differentiation of f with respect to x2. Similarly, partial differentiation of f with respect to xn. Next is Jacobian. In Jacobian, you are having vector valued function. Now how to find vector valued function derivative? Here capital F is a vector. You can see m dimensional vector because f1, f2, etc. fm, m dimensional vector. Each vector value is again a function. So function value is again a function and it's a m dimensional vector. In this case, how to find the differentiation of capital F? So that is represented by Jacobian of f. There's a differentiation of f. So what exactly you are going to do is, you know that the first value is f1 of x1, x2, etc. xn. So you are going to find the gradient of f1 of x1, x2, etc. xn, which is given by dou f1 by dou x1, dou f1 by dou x2, etc. dou f1 by dou xn. So that is the first row of the matrix. Second row of the matrix is dou f2 by dou x1, dou f2 by dou x2, etc. dou f2 by dou xn. Similarly, mth row of the matrix is dou fm by dou x1, etc. dou fm by dou xn. So if you want to find vector valued function derivative, then it will be a matrix of this form where each row represent gradient of this function. So here there are m functions and each row represent gradient of that particular function. First function, first row, second function, second row, then mth function, mth row. And each function is having n variables. So number of columns of this particular matrix is n, number of rows equal to n, m. So Jacobian of F is a m cross n matrix. Therefore, differentiation of this F is given by J of F, which is nothing but a matrix of order m cross n. Jacobian is having a vast application in neural network optimization and all those things. There are some recent papers which use Jacobian for some mathematical analysis of neural networks. If you are interested, you can go through that particular paper. Now, why I have taken this differentiation is to show you that what is the application of calculus in data analysis. If we see this particular image, it is looking like this to us. Here you are having a building, here you are having a staircase and all those things. But when you ask computer will see this image in this particular format. For computer, it is just a number. And it's a two-dimensional matrix for computer. And each value represents pixel light intensity value of that particular point. So number of pixels is represented by m cross n. Then there will be m rows and n columns, and image is represented by an m cross n matrix, where each matrix values are integer values. Now, application of image derivative is, suppose I am using the forward difference. Suppose this is my image I, and if I convolve I with this particular mask 1 minus 1, I will get ix, that is derivative of I with respect to x, that is partial derivative of y with respect to x. Similarly, partial derivative of y with respect to y I will get by applying the vertical mask 1 minus 1, that is column wise. So this is my iy. So what exactly this will give me is edges in horizontal direction and edges in vertical direction. So edge detection technique, if you see, it will make use of image derivative to find the edge. The major application of this derivative, discrete derivative in images, are to find edges of the images. There are many other steps are also there, but this is one of the major steps where you will get edges in horizontal direction and edges in vertical direction. Because if your edge look like this, when you apply the differentiation, what exactly will happen is that will become the maxima and minima points. So you are only considering the extrema points, and that you are representing as a edge fixer. That's what you are going to do in edge detection technique. Anyway, I am not going to discuss about edge detection technique because my today's job is to cover only the mathematical application in data analysis. So differentiation, discrete differentiation will be having vast application in image processing and also in neural networks. So these are the references. So if you are really interested to explore more about mathematics for machine learning, I request you to go through this particular textbook, recently published by Cambridge University Press. This is available online. So all the mathematical concepts which are needed for a good data scientist is there in this. It's a very new book. You just go through all the chapters of this particular book, and this will clear your mathematics for machine learning. Then second book that I am asking you to go through is Introduction to Statistics and Data Analysis by Springer, because only mathematics is not sufficient to become data scientist. You require statistics also. This is also the recent book published by Springer. If your college or institution is having this Springer, this one, you can access Springer books, then you can download this particular book. This is also a good book if you want to learn the statistics behind data analysis. And these are the other books. These are also available online, which you can refer for understanding the statistics for data analysis.